What's causing global warming? It's not the sun, which hasn't changed much since 1850. It's not volcanoes, which cool the Earth for a year or two when they erupt. It's not aerosols. These tiny particles and gases in pollution reduce warming as they cause clouds to reflect more of the sun's energy back to space. It's not changes in land use. The conversion of dark forest to paler pasture, which reflects more of the sun's light, has had a modest cooling effect. Is it ozone pollution? Increases in the lower atmosphere from human activity warm things a bit. Yes, it's greenhouse gases. Rising concentrations of greenhouse gases as a result of human activity are by far the biggest cause. When we compare human factors and natural factors, it's clear who's responsible for global warming.
Climate change isn't something that's going to happen in the future, it's happening now. When you alter the entire Earth's temperature, there are a lot of effects. We have a choice right now: are we going to let the Earth warm to 1 degree or 2 degrees or 5 degrees Celsius? And that decision has profound implications for our world. And so we're trying to give those policymakers some input into what their decisions actually mean. Scientists can provide those guidelines for understanding where are the greatest risks.
Over the past 2 centuries, the way we measure Earth's temperature has changed dramatically. This makes it more difficult to estimate long-term global warming. Scientists have to adjust readings to correct for changes in the way we measure temperature. For example, prior to 1940, ocean temperature was measured by throwing a bucket into the water, pulling it up, and taking the temperature with a thermometer.
But the water tended to cool down as it was slowly pulled on to deck, making these measurements cooler than those taken using other methods.
Temperature adjustments have proven a controversial topic for some. Climate skeptics have argued that scientists exaggerate warming by lowering past temperatures and raising present ones. But our analysis shows that the truth is more mundane. Adjustments have relatively little impact on global temperatures, particularly over the past 50 years. And over the full record, adjustments actually decrease the amount of warming. How much time is left before we use up our carbon budgets for different levels of global warming? As of the start of 2017, we have just over 4 years of current emissions left of the 1.5 degrees carbon budget. If carbon emissions continue at 2016 levels, the remaining budget to limit warming to 1.5 degrees is projected to run out in 2021.
When carbon dioxide is released by humans, around 30 to 40% is taken up by the oceans. The rest either remains in the atmosphere or is absorbed by the land. This causes oceans, which are alkaline, to become more acidic over time. Since the start of the industrial era, the overall pH of the world's oceans has fallen from 8.2 to 8.1. As oceans become more acidic, the number of hydrogen ions in seawater increases. Some types of coral have a hard outer skeleton made out of a compound called calcium carbonate. This compound is made of calcium ions and carbonate ions. Ocean acidification causes the amount of calcium carbonate in seawater to fall. This is because some of the carbonate ions that normally pair with calcium to form calcium carbonate instead pair with hydrogen to form bicarbonate. With less calcium carbonate around, corals find it more difficult to rebuild and grow their skeletons. This increases the chances of coral death.
The beef industry contributes to climate change in 2 main ways. First, as cows belch and pass wind, they release methane, a potent greenhouse gas. And second, cattle ranchers often cut down forests to make space for their herds. This deforestation causes carbon dioxide to be released into the atmosphere. In total, beef production is responsible for around 6% of global greenhouse gas emissions. That's roughly equal to the total emissions of the construction industry. But how easy would it be for cattle ranchers to reduce their carbon footprint? At Rothamsted Research Farm in Devon, scientists are working to come up with some answers. Over the past 6 years, researchers here have been collecting emissions data from individual animals to try to work out what causes some cows to emit more than others. The 60-hectare farm is split into 3 plots known as farmlets. The first is made up of fields that have been left unmanaged for at least 20 years. The second is made up of white clover and grass, while the third is made up of pure grass. These 3 plots allow the researchers to study whether what a cow eats can affect its carbon footprint. Graham McAuliffe is the lead researcher of the new study. His team were able to measure the emissions of each cow by weighing them at regular intervals.
An animal needs energy for growth, for maintenance, for pregnancy, lactation and so on. So we add all those requirements together and then we can estimate how much grass or silage the animals need to eat, and from there you can estimate how much methane is released. So how we were able to do that for the individual animals was because we're constantly measuring every animal from every farmlet every 2 weeks. We bring them in and we weigh them, so we've got a really high temporal understanding of how an animal performs well from week to week.
The results show that cows fed on a mixture of white clover and grass tend to have the smallest carbon footprints. This is because clover is a legume, meaning it's able to capture nitrogen from the air. That means growing clover minimises the need to apply nitrogen fertilisers.
The white clover system can have a lower carbon footprint because we don't put nitrogen on it, so that not only avoids the emissions associated with applying nitrogen fertilizer, but it also means that the upstream emissions from the actual production of that nitrogen fertilizer is also avoided from the system.
But even within each farmlet, some cows have larger carbon footprints than others. This chart shows the carbon footprints of the best and worst performing cows on each farmlet. Poor performers have the largest carbon footprints. This is because they take longer to put on weight, meaning they spend more time out on the farm where they emit more methane. The researchers say it is still not clear why some cows are lower performers than others, but it's likely to be influenced by genetics. In the future, it's possible that high-performing cows could be bred together to produce offspring that also have a low carbon footprint. McAuliffe says this technique may one day help cattle farmers to reduce their carbon footprint.
What we're doing going forward is we're actually developing a system whereby we're using genetic selection to optimise the traits to maximise performance potential. And that's an experiment that's ongoing.
However, cutting emissions from beef production can only take us so far, says Dr. Tara Garnett, who is a scientist at the Food Climate Research Network at the University of Oxford. Her research suggests that convincing consumers to eat less meat will also be important to cutting beef's carbon footprint.
There are things you can do on the production side to moderate greenhouse gas emissions from the farming sector, but they will only get you so far. And at the end of the day, high-consuming individuals and countries need to be cutting back on the amount of meat they consume.
Climate change isn't something that's going to happen in the future, it's happening now. Right now, 3% of the species are in some danger, owing only to climate change, not to all the other risk factors like habitat change. As you increase the temperature, we see an increase in those extinction risks. And so there's quite a substantial risk if we continue on our current course.